Hi everyone, my name is Amit and I'll be presenting our assignment 3 for the course CS 572. The course is taken by Professor Chris Mattmann at University of Southern California. As a part of this project, we have developed three dashboards, namely Banana, Facet View and D3 visualizations for presenting the polar data we had crawled and indexed in the earlier assignments. I will be now beginning with the D3 visualizations. Our first visualization is a dendrogram. The dendrogram helps us segregate documents on the basis of location and keywords, mainly topics. It helps us identify what number of documents are there for each topic and location. I'll now move to the next visualization. It is a bar chart. The bar chart is on the basis of frequency of documents for each topic, and the bar chart has helped us visualize certain unusual trends or unexpected documents which are featured in a corpora. One of these would be about zooplanktons, which we did not initially expect, but we have received a lot of documents. Uh, and we've also had the usual ones about the maritime biodiversity, the Arctic ice, the melting trends. So this has helped us understand that our data is quite rich. Moving on to the next one, it's called the circle packing. In this kind of visualization, the cluster size increases from the center towards the circumference. So the ones at the center are the documents which, rather topics which do not have many documents for them. And one of these documents would be about ice larvae and sea lions. So, and the more popular ones on biodiversity and melting ice are have larger clusters. The next one is called a collapsible force layout, and this is our visualization based on location of each documents. The location of these documents have, rather, this visualization has helped us understand that these documents are from a myriad sources, and the one reason we can relate to this is that the Arctic regions, the polar regions, are of national security and environmental concerns all across the globe. So this accounts for the documents from so many different locations. Our fifth visualization is a bubble chart. The bubble chart is based on keywords and topics. Again, it helps us identify the cluster size for each topic, the number of documents each topic has. For example, Arctic biodiversity has 58 documents. The Alaska information related to Alaska has 54 documents. But one unusual trend, or rather piece of information which we could extract, was about researchers. For example, Professor Blum and Hopcroft have quite a lot papers on oceans and biodiversities in polar regions. So bubble chart has helped in that way. Moving on to the last visualization, the sixth one, it's called the movie network. It is a visualization for our entire corpora. We have built a graph on the basis of keywords and locations. Each pair of documents that share a feature or a keyword or a location has been connected in the graph. So, based on this, we've got a really dense graph, but there are certain components which are still disconnected and are only connected to the root element. The graph is just coming up. Yeah, I'll try and zoom in. Yeah, the big cluster on the right is the set of documents which are strongly connected and share a lot of features and location. The one on the left are the ones which are mm, disconnected components. Um, so we're done with the visualizations. I'll now hand it over to Asitang to explain our banana and facet view dashboard. Thank you.
Mhm. Hello. So I'll be explaining the um, banana and facet view that we have integrated into our dashboard, as you can see. Let me refresh it once. Um, okay. So yeah. So it's, as you can see, it's coming up still. So yeah. So we have different panels here. One of the panels is free search, as you can see in the beginning. Um, I'll I'll use it later on. I'll explain this bar graph. It is mime type and their frequencies that we encountered. As you can see here, we have 22,000 documents here, and we can see text, HTML, text slash HTML. All those are the most frequent ones, as expected. We also have a lot of image files, and you can see in that the JPEG files are 1801, which is pretty good. Now moving on to the map, we have the map which show us the density of the color according to the frequency of documents that belong to a certain country. So we can see the most dense ones are United States of America, um, Canada, China. Um, Very unexpectedly, there are a lot of documents from Australia, um, United States of America, because the website is hosted here, and a lot of pages and scientists are from America. Canada also has a lot of documents, and we have found documents from a lot of different countries. There's a whole, there's a big distribution, as you can see: Argentina, Brazil, Portugal. We use Clavin for this. We index the geolocations using Clavin and Nudge plugin. So now moving on, we have field search. We can see which fields we have. Um, okay, this is the content. Um, didn't turn up. Well, may need to refresh it, I guess. Let us refresh it once more. Okay, so yeah. Yes, I guess this is because we have a lot of documents. Anyway, so this is the, we can do a listing of the fields that are like last modified and everything. Okay, so now moving on to the other apps, we have a pie chart where we are showing what percentage of the documents are from which countries. As you can see, a big 66% is unclaimed. Clavin was not able to detect it because of various reasons, that the document was malformed or it didn't have any content. So you can see a big part of the document that were indexed and crawled were useless. So it's very important to get rich data. As you can see, a lot of big amount of data is from US, as we saw earlier. Then, then we have this cool looking tag cloud. A lot of them are stop words, but then you can also see some important words like science. I'm pretty sure I spotted NASA in here, but I guess once you increase the word count to 200, you'll start spotting more important words here. You can do it by going here and configuring it. Um, you can configure the number of words. Mm, okay, this is the row settings. Um, yes, from here. Okay, now you can configure it to be 200, say, and there you go. So it's more dense right now. It shows more words, as you can see. Then okay, I'll quickly move on to facet view, um, which is very interesting. As you can see, the facet view dashboard here is it's showing me all the results with some very nice pictures. There's one rocket, some moon surface, and again some more rockets. Okay, so we have faceted three fields, namely T stamp, which is the time field we have. Then as I scroll down, you can see we have content. It has already put everything into different buckets, all the contents, as you can see. Yeah, do you have NASA here? Earth, mm, research, and a lot of different words. Then we have the geofields that we used and that Clevin gave us. They are the two-letter codes for each countries. We can use them as facets. Suppose I click US here and move on. So it gave me this facet, and now all the documents that have US as a location are here. Then I can provide some more facets, maybe some words. Um, if I click national, so now we have uh, all the documents that have the facet national keyword and US location. Now we can search all those documents. So this is pretty cool. We can also do a free search of anything Arctic ice. You can see sea ice index, cryosphere. I think I got a picture here as well, so you can see we got a picture here. So this was facet view. It's highly configurable, but we mostly love banana because it's colorful and it gives you a lot of insight into the data. And so this was our project. This is our dashboard, and hope you guys enjoyed it. Um, okay, thank you everyone. Thanks TAs, graders, and professor for this class. Signing off.